Hey guys, the idea today is that we film a talent on a green screen because an LED wall will cost me 2 kidneys and I really need those. Then we move the real camera, which needs to move the virtual camera, so that when we put the 2 shots on top of each other, it seems as though I stand in that virtual environment. That is the fundamental idea behind virtual production. Once you understand this, you can build further on that and make your virtual production more complex. Now, we're not gonna do live chroma keying in Unreal. You could do that as a reference, but it's not a necessary part and you're gonna need additional hardware. This tutorial is for an offline workflow so that we can do a much better keying with something like After Effects. Daddy was so kind enough to sponsor this video. They sent me a couple of TC1s and their SL1 slates, and I was like a little child, so happy when they arrived, although I'm not sure if a child would be happy to get a timecode generator for Christmas. Anyways, these timecode generators are gonna be super useful. Alright, enough yapping, let's start with step number 1.
Good, get on with it.
Design your Unreal Engine scene, and I just slapped something quick together from Quixel as an example. There we go. Step number 2. I'd like to place a meta-human or a simple character in here. That gives me an idea of the light. We can go ahead and click the menu here on top to create a new cine camera actor at the place that I'm currently am. There we go. This is the initial setup for Unreal. Step number 3. Put up your green screen and make sure it's tight, well lit, and use the reference character in your Unreal scene to match the light in your studio. I tend to take a screenshot and compare that lighting with my setup. Alright, we're ready for tripod shots, but that is boring. So for step number 4, we want to move the camera, so we're also going to need camera tracking. And here's where the first piece of hardware you're going to need comes in. Now there are super expensive systems like the one from Vicon, which is used in high-end productions, but that's not an option for us. The cheapest solution is to use a VR system. Now the one from Vive is the most recommended and best supported. And even within Vive, there are 2 solutions. Either you go for a VR headset, buying such a package gives you 2 base stations, these register the tracking, and 2 stations can cover an area of around 3.5 by 3.5 meters, which is approximately 11 feet. But you can go up to 10 by 10 meters or 33 by 33 foot if you install 4 base stations. Here in the studio, we've got 4 of those, which allows me to set up the camera anywhere I want. And I can play VR games in a weekend, which is truly awesome in such a large space. But we're not here to play games. Now, there needs to be a device that can be tracked by these base stations, and we get a lot of options here. If you've got a VR headset, you can use the controllers for that, or even the headset itself. Now, it's not so user-friendly though. That's why Vive also has these trackers, which have a mounting option on the bottom, much easier to connect it to your camera. So once you've got that installed, you just launch Steam VR, and then you can find the trackers back in Unreal. But there's also a different solution from Vive, and that's the Vive Mars, which is specifically designed for virtual production. Now, if you get the Mars box, it comes with 2 base stations, we already know what they do, and 3 trackers, so that stays the same. But it also comes with the Mars, and this is essentially the brain. The trackers are also complemented with these adapters, which they call the rover. This allows you to connect the tracker into the rover and then connects that rover onto the Mars. So instead of transferring everything wirelessly, you got cables, which is more accurate and reliable. I can connect 3 trackers to the Mars, but we'll leave it at 2 for now. One goes to the camera, and I'll put another one on the floor. The Mars gets connected with an Ethernet cable to your network, and it doesn't require you to launch or even install Steam VR. You just open Unreal and the Vive trackers will automatically be there. Step number 5, time code. So we've got a real camera and a virtual camera. It's like recording audio and video separately. Now we need to synchronize those 2 signals. Unfortunately, we cannot just clap our hands as Unreal Engine is not a sound recorder. So that's where Daddy comes in, which is absolutely the best and most affordable solution out there. You can get these timecode generators, which you connect to your camera. And the cool thing is that this works with almost any camera, as you can also plug it into the microphone jack. It will then write its timecode to the audio channel, but it also records audio itself because there's a small mic on the TC1, so you'll still have reference audio, which is super useful. Now I've got a pack with 3 generators, so one goes to the camera, I can hook another one up to the Mars, and if needed, another one to a sound recording device. Now what's very interesting about these generators is that we can connect them to their app, Sidus Audio. You'll find all your devices in here as well as their slate, which I'll get into in a moment. The idea is that we set one box as the master. This one is going to determine the time code. All the rest needs to follow, so we set them to jam. So that means we can change all the settings further on the master. We need to set the right frame rate here, so let's go for 30 FPS. There are also a bunch of channels if you're working with multiple sets or crews, but that's not needed for now. Finally, we can select the output, either L out or A out. A out is for if you don't have a sync port on your camera, as mentioned before, but the Daddy should automatically recognize that. And that's pretty much it. It is very important to use one brand and multiple timecode generators because there could always be an offset, or by the end of the day you'll see that one device is like a frame or second behind. Now they also have a slate which goes into the app as well, and it has a beautiful unibody aluminum design with wooden sticks. It feels super solid and it is built for one-hand control as well. There's a backlight, so even in dark scenes you're able to see what's on the slate. On the back there's a menu to change a bunch of settings, but we can do everything from the app, which I recommend. You get over 25 hours of battery time and it has 2 batteries. That means you can swap one out without having to disconnect the slate. It's truly amazing product and you can learn all about it by clicking the first link in the description down below, guys. Alright, step number 6. Let's connect that camera tracker to Unreal Engine. And the first thing you want to do is head over to the menu on top and select plugins. From here, search for LifeLink, and we want to enable the standard LifeLink plugin, but also the LifeLink lens plugins. We're going to need that later on to get the lens information from the real camera into the virtual camera. Otherwise, your tracking is not going to work properly. Finally, look for camera calibration and enable that plugin as well. Then just restart Unreal, and once it's back up, we can go to the window menu on top and under virtual production, choose LifeLink. Click on source, message bus source, and you'll find the Vive Mars in here. Then on the bottom, you'll find all the trackers that are currently connected to the Mars. We've got one on the camera, which is the Rover 1, and Rover 3, which is the tracker on the floor. Now, some people have trouble connecting the tracker to LifeLink. Unfortunately, there are many causes, so I can't really give a straight answer. You can try to disable your firewall, or if you go into the project settings in Unreal, check UDP messaging on the site. Switch the IP address and unicast endpoint and see if that solves the issue. Alright, step number 7. We're gonna link the tracker to the camera. So select your camera actor and in the details panel, click on Add, and we're going to look for the LifeLink controller. Then with that component selected, we can assign a subject to it, which is gonna be the Rover 1. And that's pretty much it. When we now move the real camera, the virtual camera will move along. Now what I'd like to do next is select my MetaHuman and also add the LifeLink component to it. Here we are going to assign the Rover 3 to it, which is the one on the floor. Now this is all optional though, but if you place the floor tracker on the spot where you're going to stand, it gives you some kind of a representation of the distance between the camera and the subject. Step number 8. There's a problem. The camera is floating somewhere and we can't move it to a different spot because its position is controlled by the tracker. To solve that issue, we're going to go to the Add button in the viewport, choose Basic and then Actor. This is a nothing object. It doesn't do anything, but we can attach the camera and the MetaHuman to it by just dragging those into the actor. So now we can freely move the actor around, see it as a group, and place the camera where we want it to be. Now one thing to keep in mind though is that you want to place the actor at the same height level as your floor. In this case, that would be 0. However, the tracker sits on the rover adapter, which is 5 centimeters high, so you want to add 5 to the Z position of the actor. Step number 9, the lens data. And as you know, the virtual camera has its own focal settings, and unfortunately, it's not as easy as just typing in the millimeters from the real lens. Plus, the tracker sits above the camera. This is called the nodal offset, and that needs to be calculated somehow. Now, if you have the Vive Mars, it comes with a lens calibration tool. I'm not going to show you how that is done, as Vive has their own tutorial and it's pretty easy, but you'll end up with a lens data file. You can just import that lens file into Unreal, then select the camera actor again and add a new component. This time add lens to it, and from that component we can assign the lens file. Finally, set the evaluation mode to use camera settings, and don't forget to enable distortion. That will set the focal length and everything else the same as the real camera. Step number 10, we've got the timecode running thanks to Deity. Now we just need to bring that into Unreal as well. For that, we're gonna have to right click in the content browser and choose to create a new blueprint. Expand all classes on the bottom and look for LifeLink timecode provider. Give that a name and open it up. On the right-hand side, set the subject key to either one of the rovers. Hit save and compile. You can then just close that window. Now going into the project settings, look for timecode provider. From that drop-down menu here, you should be able to find the blueprint that you just created. Select that one and we've got timecode running into Unreal. Thank you so much, Deity. Step 11, and I'm missing a finger here. Just assume my head is a finger as well.
Yeah, sure. Weirdo.
We're almost there, guys. Everything is set up so we can start recording. Go to the Windows menu, Cinematics, and choose the take recorder. If all went well, you should see your timecode running in here. Everything that you're gonna move around and want to record needs to come in here. So that's gonna be the cine camera actor, and we're also gonna need the attached actor to retain the correct world position. So we can start the recording sequence. All right, everybody ready? Sound.
Rolling.
Camera.
Rolling.
Unreal Engine.
Recording.
And
action!
And congratulations, your first virtual production is a fact. You can find your Unreal recording back in the cinematics folder. Just open up the correct scene from which you can preview it. And on top, you'll find the render button to export it out as a movie. Then loading both into a video editing program like Premiere, we can easily synchronize the Unreal scene, the camera shots, and if you have audio as well, the audio recording, because they all have the exact same timecode running. Then just pull your green key and you're done.
Hey, here we are inside Unreal Engine. The camera is panning, we got some movement, although the space is a little bit empty here, isn't it? I should have put more stuff in here. Anyways, it's working. Hey!
Now, if Unreal Engine is still new to you and you want to learn all the basics for using Unreal Engine for filmmaking, like how to get DMX to work, perform a live green keying and whatnot, check out my course in the description down below. And I'm going to give the first 100 people 50% off, so you definitely don't want to miss out on that one. Thank you so much for watching, and as always, stay creative.